Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling question number 4 from the mid-year examination, which was written in the year of 2024 in the province of Eastern Cape. Please do note that guys, the other questions are already uploaded, and please do expect a total number of 9 videos, which I am only focusing on physical science paper 1 from the Eastern Cape. Each and every question will have its own video, and please guys, do note that knowing how to tackle exam questions will give you an edge whenever you write your mid-exam as well as your preliminary exam, but most importantly when you write your final examination. So please do take this seriously guys, because I strongly believe it will give you an edge whenever you write your exam. So please do share the video to your peers, because they deserve to have the edge as well. And please do help us grow the channel by just subscribing. Okay. Ball A is thrown vertically upwards from the bottom, which is also the foot of a building which is 8 meters high with a speed of 15 meters per second. And then after 0.5 seconds, ball B is also thrown vertically upwards from the top of the building, and then both balls reach a maximum height at point P at the same time as shown in the diagram below. I must just ignore the effects of air friction. Okay, so the motion for ball A will simply move like this. From the ground, it will go to maximum height and then come back to the ground. According to time symmetry, if the velocity of the ball is 15 meters per second, if the speed is 15 meters per second over there, when the ball returns to the same position, the speed is also 15 meters per second. But in vertical projectile motion, we do not deal with speed, we deal with velocities, and velocity should have both magnitude and direction. Let's say for this question, we choose upwards as positive. That means the velocity at the initial position will be positive, but the velocity when the ball returns to the point of projection will be negative, because the ball is moving downwards. So if we can call this position A, position B, and position C. A is the initial point of projection, B is when the ball reaches maximum height, and then C is when the ball returns to the initial point of projection. I know that the speed, or rather the velocity of the ball at maximum height, is always equal to 0 meters per second. Oh, it's good. There's something guys I want us to note, is that the time it takes for the ball to move from position A to position B, from position A to position B, is the same amount of time the ball will take to move from position B to position C, according to time symmetry. Are you together? And obviously the distance it takes the ball to move from position A to position B, it's the same distance. It's the same distance the ball will travel from position B, returning to the initial point of projection. Please guys, do not forget these things whenever you deal with time symmetry. Okay, now let's focus on the motion of ball B. Ball B is thrown from a certain height. It goes to maximum height. It passes the point of projection and then reaches the ground. So we can call this position P, Q, R, and S. All we know is that at position Q, the velocity of the ball will be 0 meters per second, because Q is the maximum height. Actually, let me call this P. That's QPR. Remember that guys, we were told that both balls reach the same maximum, the same maximum height. Okay, so the maximum height will now be represented by P in all the scenarios. Okay, and please note that guys, since both of these balls reach the maximum height at the same time, that means whenever the two balls are at position P, or rather are at height P, they will reach the same height at the same time, and that height will be the maximum height for both balls. That simply means that the two balls A and B will reach the ground simultaneously as well. Are you together? Because they are both traveling under free fall, and if they have the same initial velocity at maximum height, it simply means that they will have the same velocity whenever they reach the ground. But let's continue, guys. We are being asked to define the term projectile motion. Now, projectile motion, guys, is when an object is given an initial velocity, and that object is traveling under the influence of gravitational force only. Okay, and then now they want us to calculate the time it takes, the time taken for ball A to return to the ground. Okay, we can simply take our information from position A to position C, right? Position A to C, I know that my initial velocity is positive 15 meters per second. The final velocity will have to be negative 15 meters per second. The acceleration, if I choose up as positive, my acceleration will simply be negative 9.8 meters per second squared. Delta y, the ball started from the ground, it returns to the ground. That means the straight line change in position will simply be 0 meters per second because the ball returned to its initial position. Yeah? But I don't know the amount of time it took the ball to return to the same initial position. That means I must use any equation that has time. The only equation I shouldn't use is the one that says, is the second equation that says Vf squared is equal to Vi squared plus 2g delta y, because that formula does not have time. No? Okay, the easiest formula that has time, it simply says Vf is equal to Vi plus g delta y. The final velocity, that's negative 15, initial, that's 15, gravitational acceleration 9.8, I'm looking for delta t. Né? When I take the 15 to the other side, I'll simply have a negative 30 is equal to negative 9.8 delta t. If I divide both sides by 9.8, negative 30 divided by negative 9.8, this will simply give me the amount of time taken by the ball to reach maximum, to return to the ground rather, as 3.06 seconds. So it took 3.06 seconds for the ball to return to the ground. That's 3.06 seconds. Okay, since it took the ball 3.06 seconds to return to the ground, it simply means that half of the time the ball was traveling to maximum height, and for the other half, the ball was traveling from maximum height to return to the ground. Are you together? Okay, now they want us to calculate the speed at which ball B is thrown. Yeah? Firstly, I want us to deal with the time. Okay, but let's write whatever information we have. Nah? We are focusing on ball B now. The initial velocity of ball B, that's what we are looking for. We can take information from position Q to P, the initial position to maximum height. The final velocity will simply be 0 meters per second at maximum height. Acceleration, that's negative 9.8 meters per second squared. Delta y, I do not know the height reached, I do not know the maximum height reached by ball B. And then now the time. Let's deal with the time now. Okay, remember that, guys, I said to you, this is the time it takes for the entire motion. Are you together? But I know that half of the time was spent when the ball was approaching maximum height, and the other half will be spent when the ball returns to the ground. Okay, now let's deal with that. Now, for me to calculate the amount of time it took for ball A to reach, to move from A to B, all I have to do is to say 3.06 divided by 2. And then this will simply give me 1.53 seconds. Are you together? So ball A reached the maximum height after 1.53 seconds. But remember that I was told that ball B was thrown 0.5 seconds later after the first ball was thrown. However, they reached the maximum height at the same time. So that means the time taken for ball B to reach maximum height will simply be equal to 1.53 minus 0.5 seconds, and then I'll simply get 1.03 seconds. This is the amount of time it took the ball to reach maximum height. Are we together? Because both of these balls reach maximum height simultaneously. However, the other one was projected 0.5 seconds later. That's why I had to find the difference between the two times. Okay, I'm looking for the initial velocity and I do not have delta y. This simply means I'm not supposed to use any formula that has with delta y because I wouldn't find my answer. So the only formula that doesn't have with delta y is the first one that says Vf is equal to Vi plus G delta T. My final velocity at maximum height, I have 0. I'm looking for the initial velocity, the gravitational acceleration, that's 9.8, and the amount it took for the ball to reach that maximum height is basically 1.03. So therefore the initial velocity is basically a negative 9.8 times 1.03. I'll simply get 10.1, because after finding the answer I just need to take it to the other side, né? Yeah, and then it will be positive. That's 10.1 meters per second upwards. Velocity has both magnitude and direction, né? It's upwards. Or they wanted the speed. Okay, so the speed is just 10.1 meters per second. If they said, guys, they wanted the velocity, you are supposed to include that upwards, né? Okay, and then now they want us to calculate the height h. The height h. How can you find the height h? Let me create some room for me to write over there. The height h. Okay, there's something that, guys, I want us to see over there, né? Firstly is that the maximum height reached by ball A will simply be equal to the height of h plus the maximum height that will be reached by ball B. If you can check, this is the maximum height, right? This position over there. So the maximum height will be equal to this part over here plus that part over there. And that part is just the maximum height reached by ball B. So that simply means that for me to find h, I just need to subtract the two maximum heights. The maximum height at A rather, minus the maximum height at B. And then I will find the height of h, né? So I think it will be easier for me to find the maximum heights. For ball A, né? Let me write this. For ball A, I'm moving from position A to position P. The initial velocity, let me write over there so that I'll have room. I'm moving from A to P. The initial velocity is positive 15 meters per second. Final velocity, that's 0 meters per second. Acceleration, negative 9.8 meters per second squared. Delta y, that's what I'm looking for. And the amount of the amount of time it took for the ball to reach maximum height is 1.53 seconds, né? But guys, I calculated that time on my own. Maybe I made a mistake. So for me to not lose marks, let me refrain from using the answer I calculated on my own. I was going to use it if I was pushed to do so. Are we together? But if I do have other options that can give me the answer without using the values that I calculated on my own, I'll just choose those ones, né? Okay, so I'll simply say VF squared is VI squared plus 2G delta Y. The velocity squared is 0. I have 15 over there plus 2 times negative 9.8 delta Y. When I take the negative 15 squared on the other side, I'll simply get negative 225. This is equal to negative 19.6 delta Y. So my delta Y will simply be negative 225 divided by 19.6. 19.6. I'll simply get a height of 11.48 meters. Okay, and then for ball B, we are moving from position. Yeah, let me continue writing there. Né? We are still moving from position Q to P. We are still moving from position Q to P, right? We did find our initial velocity to be 10.1 meters per second. Let's use the same equation to find the maximum height reached by ball B. Vf squared is Vi squared plus 2G delta Y. The maximum height is 0. The velocity at maximum height is 0, right? And then the initial velocity, that's just 10.1 meters per second squared delta Y. And then I'll simply have negative 10.1 squared is equal to negative 19.6 delta Y. Therefore, delta Y is equals to 10.1 squared divided by a negative 19.6. This will simply give me 5.20 meters. So therefore H is basically max height at A minus the max height at B. That's 11.48 minus 5.20. 11.48 minus 5.2. This will simply give us an answer of 6.28 meters. So the height of H is just 6.28 meters. That's basically 6.28 meters. Okay, and then now we are being asked, how does the velocity of ball A compare to that of ball B in the instant when the two balls hit the ground? Remember that, guys, I did explain initially that when both of these balls will reach the same maximum height at the same time. That means whenever they reach the ground, they will reach the ground at the same velocity. So the velocity is the same. Are you together? The velocity is the same. The reason behind that is because they are both accelerating. It's because they have the same acceleration, or rather say both balls are under free fall. They have the same acceleration. Né? Then now they want us 4.3. We are told that on the same set of axes, sketch the velocity time graph for the motion of the balls A and B from the moment they are thrown vertically until they reach the ground. Okay, I'll simply have this velocity time graph. I'll have time on my horizontal axis, time in seconds, and then velocity in meters per second. Okay, so ball A was first projected at an upwards velocity of 15 meters per second. It then went to reach maximum height and then returned to the ground. at a velocity of negative 15 meters per second. The amount of time it took, it was just 1.53 seconds to reach maximum height, and then it also took 3.06 seconds to return to the ground. Now, but ball P was thrown. Ball P was thrown. Ball P was thrown 0.5 seconds later. Ball P was thrown 0.5 seconds later. So the graph will simply be like this for ball P. That will be just 0.5 seconds later at a speed of 10.1. That's how, guys, we're supposed to draw this thing over there. Just know that after maximum height, they both have uniform motion. That's why I've drawn the graph of B on top of the graph of A after maximum height. Yeah, so that's how, guys, we're supposed to excuse me, that's how we're supposed to tackle this question over there. And I really hope that the video helped you out, guys. Yeah, just stay tuned and wait for more videos. Thank you.